Hi, Doc Revis here. In this video, I'm going to teach you how to calculate the molar mass and percent composition. Let's start with molar mass. Molar mass is given in units of gram per mole. So, molar mass is the gram per mole of a compound based on the molecular formula and the elemental molar mass values from the periodic table. To show you how to carry out the calculation, we're going to use carbon monoxide as our example. To do this calculation, we need three pieces of information. We need the atom count, we need gram per mole, molar mass, of the particular elements from the periodic table, and then we need to set up a mathematical equation. If we take a look at carbon monoxide, we notice that it's composed of 1 unit of carbon and 1 unit of oxygen. On the periodic table, we find the following molar mass: 12.01 gram per mole for carbon and 16.00 for oxygen. Since there's 1 unit of carbon, we multiply 1 times 12, and since there's 1 unit of oxygen, we will multiply 1 times 16, and we will sum these values for a total of 28.01 gram per mole. Let's do another example where we have carbon dioxide. Carbon dioxide, if we take a look at the atom count, is 1 unit of carbon and 2 units of oxygen. 2 units of oxygen because we count the number of atoms using the subscripts to the bottom right of the elements. So we have 2 units of oxygen and 1 unit of carbon. Periodic table, molar mass, and we multiply times the number of atoms of each of the elements. We sum this data and we obtain 44.01 gram per mole. Next, let's turn our attention to how to calculate the percent composition. Percent composition is the ratio of the molar mass, which we abbreviate in this case as MM, of the element in question to the total molar mass of the compound times 100. So, if we want to find the percent carbon in carbon dioxide, we will use the equation shown here, where percent carbon would equal to the molar mass of carbon divided by the molar mass of carbon dioxide times 100. We complete the calculation by plugging in 12.01 for the gram per mole of carbon and 44.01 for the gram per mole of the total compound, which is carbon dioxide. Note here we've omitted the units because they cancel out. So the percent composition here is 27%. Let's say now we want to calculate the percent oxygen in carbon dioxide. Notice in the case of carbon dioxide, there are 2 oxygens that we have to account for, shown in this diagram with the red circles. So we carry out the same type of calculation, but in this case we have 2 units of oxygen times 16 for the numerator. The denominator stays the same at 44.01%. We do the calculations and we obtain 73% oxygen. So, in conclusion, what we discover is that carbon dioxide has a molar mass shown in red here of 44.01 gram per mole, which is composed of 27% carbon and 73% oxygen. We note here that this composition conforms to the law of definite proportions, which tells us that a compound has a fixed molar mass and a fixed percent elemental composition based on its molecular formula. So how about some other examples of molar mass and percent composition? Take a look at water. Water is H2O, 2 units of hydrogen, 1 unit of oxygen. We get the molar mass from the periodic table. We plug in the values. We multiply 2 times the 1.01 because of 2 units of hydrogen, 1 unit of oxygen. We sum the values, and there we have 18.01 gram per mole of water for its molar mass. If we consider the percent composition, we know that percent hydrogen would be 2 times the molar mass of hydrogen divided by the molar mass of water times 100 for 11%, and oxygen would be 1 times 16 because there's only 1 unit of oxygen in water, H2O, So it will be 1 times 16 divided by 18 times 100 for 89% oxygen. So what if we want to determine the molar mass and percent composition of the elements in magnesium hydroxide? Well, we would carry out the same process. In this case, we have 1 magnesium and we have 2 hydrogens because of parentheses. And we also have 2 oxygen because, again, the parentheses. We look at the periodic table and we record the molar mass of the elements from the periodic table. We plug them into the equation: 1 unit of magnesium, 2 units of hydrogen, 2 units of oxygen. We do the math and we sum for 58.32 gram per mole. If we wanted to determine the percent of each of the elements in magnesium hydroxide, we would take magnesium molar mass times 1 unit divided by the total molar mass times 100 for 42%. Hydrogen would be 2 units of hydrogen times this molar mass divided by the molar mass of magnesium hydroxide, which we've already calculated, times 100 for 3%. And for oxygen, we would have 2 times 16 divided by its molar mass times 100 for 55%. There you have it. This is how we calculate molar mass and percent composition.